All right, so today we're starting a new unit. It's a lot of, I guess you could call it like data analysis. We're just looking at graphs. We're learning how to read them. And today we're learning how to make our own scatter plot. We're only going to do one in our notes. So we're only doing example one. I know there's several other examples, but after we do this example, we're just going to go straight to big ideas and start working on the homework. All right, it's just a little bit more user-friendly to do the assignment in big ideas. But just starting out, we at least need to do one. So we are all on the same page, basically what we're looking for. Just make do with what you have for now. Do you have anything? All right, so there's three terms, okay? There's three terms that you need to know. Every scatter plot that we look at, okay, we're looking for outliers, gaps, and clusters. Outliers are values that kind of skew away from the pattern. So they're just like random values just off to the side. All right, gaps. What I want you to notice about gaps is we're looking for gaps between the x values, mainly between the x values. We can identify a gap with the y values, but normally it's gaps in our x values. All right, so go ahead and put x in between those two words. So we're looking for gaps in our x values. And we're also looking for clusters around specific x values as well. All right, so it's really those x values that'll help us see, okay, is there a gap in our data? Is our data clustered in a certain area? And all of that really helps me figure out, is this an accurate picture of whatever I'm trying to assess or whatever data I'm collecting? All right, if you have a huge gap, meaning you have this whole chunk of information missing, that might not be accurate. All right. Okay, so let's look at example one. And let's look at the scenario, and that'll help us understand what all these numbers mean. All right, it says the table shows the ages of what? 10 adults and the number of gigabytes of cell phone data used. Does anybody know about how much cell phone data they use? Do your parents tell you? So you can actually look on your cell phone bill. And I'm sure most of us are on unlimited plans, right? So we don't really care about the data. But you can look on your cell phone bill and see how much data you're using. Do you guys stream stuff like music, movies, Netflix, all that? So that uses more data. That's what's happening here in this chart. What it says is there's a 37-year-old, okay, look here. A 37-year-old used about 3.2 gigabytes of data in 1 month. That's nothing. That's absolutely nothing. That's so minimal. All right, but we'll go with it. Okay, so the first thing we need to do is we need to set up our values on the X and Y axis. All right, so I'm going to go ahead and just give you those values. But notice, all right, when you're setting yours up, notice that I skipped every other block. All right, so that means the blocks in between are my fives. All right, so 5, 10, 15, 20, yes.
Can I have Anna Walker to go home, please?
Yes, ma'am. Okay, so I went by tens, but I skipped every other block. Go ahead and do that on your chart right now. Okay, same thing with the gigabytes. I skip a block every other one, and I went by ones. All right, so go ahead and do that. This is gigabytes, right? This is data. I'll just do, hold on, I have the highlighter. I'll just do GB for gigabytes. That's a terrible B. It's hard to write sideways. Okay, that was a little bit better. All right, so those are gigabytes, and then I have my age across the bottom. So I'm going to plot my first ordered pair, which is the 37-year-old that used 3.2 gigabytes of data. All right, so I go over just past the 35, and then I go up just above the 3 to plot about 3.2. All right, so I follow the age, and then I go up to their usage, which was about 3.2. All right, and I'm going to do that for all 10 users. So how old was the next person? 30. So I'm going to go over to 30. And how much data did they use? 3.3. So I'm going to come up here about halfway between 3 and 4. And I'm going to plot that point. All right, for 3.3. All right, how old was the next person?
32.
32. So I'm going to go over just past the 30. And then I'm going to go up to 3.1. So that one's going to be really close to the point I just plotted. All right, it's going to be really close to it. Okay, now I'm going to do the 65-year-old. 65-year-old. All right, they're way down here. They only used 0.9 gigabytes of data. So then I plot that point way down below. All right, and then the 53-year-old. So I go over to 50, about halfway between 50 and 55, and I go up to 1.8, which is just under the 2, and I plot that point. All right, I want you to go ahead and do the last 5. So we have the first 5 up there right now. I want you guys to get the last 5 points on your scatter plot. All right, go ahead and do that. Okay, so are your 5 points, did yours look like this? Similar?
Somewhat.
Similar, somewhat, okay. All right, so just look up here. All right, so we've got all the points plotted. This is really similar to a couple of your homework questions that we're about to look at in just a minute. All right, so now that I have the points plotted on my scatter plot, now I want to identify, are there any outliers here? Any values that kind of go away from the pattern of values? Do you see any values that kind of go away from the pattern, Chase?
The 65-year-old.
I mean, but they're still kind of on the trend, right? Hamir, what do you see? Not 25, but the 30-year-old down here. Do you see how most of the values are kind of trending downwards? But then you have this one random 30-year-old. Maybe they're not allowed to be on their phone at work and they work a lot, but for whatever reason, their cell phone usage doesn't really align with what the pattern is. So my outlier is going to be 30 and 1.8. All right, so basically that person didn't really follow the trend. Now, do we see any gaps? Remember, when I'm looking for gaps, I'm looking at the X values. Do I see any gaps in the ages?
40.
Do you see anybody that's in their 40s? No. So to identify the gap, you're going to choose the value that's basically on the highest part of the low side. So this one was what age? 37. And then on the other side of the gap, what's the next age after 37?
Can I have John Hart?
Okay, so between 37 and 50. Okay, between 37 and 50. There's nobody that's between the age of 37 and 50. So we don't have any information on how much people in their 40s use their cell phone. All right, so that gap is an issue if I'm trying to say that my data is accurate. All right, what about clusters? Does anybody see data that's really grouped together kind of tight?
Between 30 and 40.
Okay, what do you guys think? Between 30 and 40? Or maybe even close it in a little bit more, between 30 and 37, right? So we see a cluster right there. Now your book says between 25 and 37. They included this one, but I don't know if that's really part of the cluster. To me, that doesn't seem like part of the cluster. All right, so if you said 30 to 37, I feel like that's a little bit more accurate. All right, so learning how to read scatter plots. We're looking for gaps, clusters, and outliers. Yes?
Are we doing what the book says or what you said?
Either one. It'll be a lot more clear on your test, how I worded it on your test. So we're not too worried about that. All right? So now let's talk about the relationship between age and data usage. What do you guys notice about the data usage as the ages increase? What do you guys notice about the cell phone usage?
It goes down.
It goes down. So we call this a negative relationship. We're about to go over the relationships in just a minute. As the age increases, what my pattern shows is that the cell phone usage decreases. I want you to write that down. All right, so you're always going to be asked to interpret the data. The interpretation is, how is X and Y related? As age increases, yes, you need to write this down underneath example 1. Yep. As age increases, cell phone usage decreases. Now, that's not necessarily like a fact like for the entire world or all of America. It's just these 10 people, that's the conclusion that I can draw. As the age increased, the cell phone usage decreased. You guys see how we did that? All right, so let's talk about the relationships. So the last example was a negative linear relationship. We saw, aside from the outlier, we saw age increasing and cell phone usage decreasing. So a positive linear relationship says that as X increases, so does Y. All right, so let's think about, you have one question on your homework tonight that says, okay, what is a real life example of a positive relationship? So what kind of scenario would we say as X is increasing, so is Y? I'll give you one. All right, the more calories I eat, the more weight I gain, right? I wish it wasn't that true that way, right? Like the more food I eat, the less I weigh. But that's not how it works, right? The more calories we eat, the more weight we gain. That's a positive relationship because as X is increasing, as you consume more calories, your weight is also going to increase. All right? Maybe not the best example, but that's all I could come up with for now. All right, nonlinear shows a decrease in X and Y relationship, and then it levels off, and then it increases. So that's nonlinear. And then no association at all is there's no pattern. All right, so last thing we're going to cover for today. All right, look at this graph. What is this graph showing us? What is it telling us? Look at your X value and look at your Y value. All right, so the first thing I want to do is I want to identify, is this a positive relationship? Is it a negative relationship? Is it nonlinear? What am I looking at, Chase?
Positive.
Okay, he says positive. Do you guys agree? Yeah. It's positive. Okay, so we say positive. Can we put this into a sentence? All right, so we said positive, but let's look at the categories. As the television size increases, what happens to the price? The price increases. And again, I mean, wouldn't it be nice if that was a negative relationship? The bigger TV, the less money it costs. But you walk into Best Buy and that's not reality, is it? Okay? All right, so we're going to write that as a sentence. As the television size, you can abbreviate TV, size increases, price or cost also increases. All right, so again, if X is increasing and Y is increasing, that's a positive relationship. As the TV size increases, the price also increases. And that's all your homework is covering tonight. They want you to read scatter plots. They want you to determine, is it a positive relationship? Is it negative relationship? Where are my outliers? Where are my gaps? Where are my clusters? That's all you're doing in those questions. All right, but I do want to give us a little bit of time at the end of class to get started on that. So this is all the information really that you need to know from this section in order to be able to do your homework tonight. Okay?